Hi there, today we will be looking at basic mathematics in Python. In fact, it wouldn't stop at basic mathematics, but we would cover a lot of mathematical operations in Python. So if you're wondering how you could perform mathematical operations in Python, this is a perfect video for you. I would touch almost all the functions that we have, or all the mathematical operations that are available, or how you could perform most of the mathematical operations in Python. And so without waste of time, let me just create a notebook and let's get into it. And so we'll start with the basic ones, which is the basic arithmetic. And so with the basic arithmetic, you have things like plus, you have things like plus, you have things like minus, you have things like times, multiplication, you have things like divide, and then you have a floor division, and then you have things like mode, and then you have things like raised to the power. So let's use each of these. And so the first is times. So the first is plus. So for example, you have a variable a is equals to 3, and you have a variable b equals to 5, and then you could see say c is equals to your a plus your b. And so if you print what is your c, that will be, make this big a little. Okay, I think that's almost too big, but hopefully you can see. Yep. All right. And so yeah, so you print that. Of course, you add these two numbers, you get the 8, and that's the c. But also you could do things like minus. So you could do a b minus a, and that would just give you that value. But let me split that so that I could see the value. It's 2. So it's just doing this minus this is that 2. So that's just how you do minus, just a normal way. You could do a times, a b times a, and that will be 15. That's just a multiplication. You could also do divide, b divided by a, from a fraction. This will give you this number, which is what you get. And you could do a floor, which is just like you don't need remainder, and so it will like round it up. And so if you do a double that, it will like give you an integer, and it's a floor. And if you just strip it off at the whole number, so it wouldn't do any approximation, so there's no round up there. And also you have a mode, which is just for grabbing the remainder. So if you do this divide by this, which is b at the top and a at the bottom, then there's a remainder basically, and that remainder, this will go into this perfectly at one time, but there's a remainder of 2, and that's what you get here. And so you could also do a raised to power, and so you could do a b raised to the power of a, and this is the number that you get. In MATLAB, you have to do like this raised to power. If you try that here, we get something wrong. Okay, so the power is times 2 times, and so for example, if you do 2 raised to the power of 3, that would be 8. What if you do 2 raised to the power of that way? You get a 1. So that's not the same. So that's why this video is crucial, just for you to know how to do this operation. Now let's go into the input functions. And so there are other things like absolute. So if you have a value, say minus 5, let me just say alphabet f or variable f is equals to minus 7. And if you want to find an absolute value of s, you just want to do abs and then pass in f, and that will give a positive value of 7 basically. And that's up to the absolute value, which is basically squaring this 7 and taking square root of that value, and of course a negative. So basically absolute in mathematics is just doing the minus, doing the 7, since you have it in f, taking a square of f and then taking a square root of f. And so you could use something like np dot square root, but we'll have to import the NumPy first, so that's what we wanted. But let's just import that. So we import NumPy, which is a numerical computation and dimensional array kind of package as NP, so it has a lot of tools that you may need. And then if you take square root and square that, then it gives you back this. And we could also convert this back to an integer to make it look exactly the way we had it there. So it's a 7 there. There's also what is called power. And so instead of like doing it this way, you could also do it this way. So you could do something like power of b comma a. And so this is just saying it's b a raised to the power of this guy. So b raised to the power of 2. So if you run that, you get the same value as if you do, run this, well, we did it before, and if you run this, you get the same answer. So that's another way of doing a power. You could also get the quotient and the remainder by doing a div mode. So there is another function called div mode. So you just do the divisor, and it gives you a quotient and the remainder, basically 3. And so that's that. It tells you how many times it will go into and the remainder, basically. So the remainder in this case is that 1, and how many times it will go into is the 3. So that's a division. It gives you the division and the mode, so it's kind of div mode. And there is also another package inbuilt for Python that is called math. So if you just do import math instead of NumPy, most of the stuff contained in NumPy also in this math. So if you don't want to use NumPy, which you have to install, then this one is inbuilt, is math. And so in the math, we have things like math.square root. So for example, instead of doing what we did before, we could do math.square root, which is sqr of say b of say f, for example. If you do a square root of a negative number, don't want to go into that now because we'll get there. Square root of b will give us that value. So that's how you do square root. There's also a floor, which is this slash that I did before. I could also do that with this result. For example, if I do a floor of this value by 1, then it just grabs just the first value. But if you don't want to do floor this way, there's also something in math called floor. So do math.floor of b divided by a. We just want something that will give us a float, and then it's able to grab just the front. Ordinary, if you just do b divided by that, that will give you this long number, but now it's flooring it, giving you just that value. Here's also a math.pi. So the pi is a 3.142, and it can go forever. If you don't want to manually be defining stuff like pi is equals to 3.142 whatever, then you could use the math. So there is a math.pi, and if you do that, it will give you the value of pi. So that's the value of pi that I just provided here. There's also exponential, there's log. All of them are contained in this particular, so you just have to do a math.log and then pass in whatever log default that you're looking for. And there's another one for complex numbers, and that is called cmath. And so you could have something like so first you have to import it. So you have to import cmath, so complex math. And in the cmath, you could do something like maybe c is equals to complex. Let's do a complex number, and in the complex number, let's provide in 3, which is the real component, and the imaginary to be 4. So if we run that, then we'll have a z. Then with the cmath, we could begin to do things like square root. So we could print, for example, what is the value of the square root of this particular complex number c. So we could do something like cmath the square root of z, then close that, and if we run that, then it gives us, that's the value, that's the square root of z. You could even do an exponential of z. So let me just copy that and paste in here, and then we could change this to an exponential, so e to the z. It didn't like that. Okay, sorry, it's supposed to be exponential, so that's the exponential value. You could even find like in angles, you could find like the face, for example. You could even do something like, let's copy this and paste it here and change this to a face. And so we could do something like face of z. It will give us the face of z, and so on and so forth. There's also another good package called random that you could use to generate random numbers. And so for example, if you want to give out something, a gift to someone, you want to randomly select from a seed of collection of numbers, then random is great. So you could import random. This is also inbuilt in Python, and so you just have to do random. And so if I run that, that will import the random package, and in the random we do rand.int. That would like randomly give us integers between a certain range. And so we could do random dot we could do something like rand.int rand and then integer, and then it should go from 1 to 10. That's within where we need the value, and it could randomly pick a value in between. So you could even make this to 3. The number should be different. So it's just selecting values within our set range. Okay. There is also a random.uniform, which is like a random float between a certain range, but in this case to be uniform. So we could do something like random dot uniform, and we could pass in, maybe it should go from 2 to 10. And if we run that, then yeah, randomly selected a value for us. There's also a choice where you could pass in a list, and from that list you ask it to randomly select something. And so for example, you could do something like random dot choice. That's not choice is IC choice, yeah. And then you could pass in a list, and this use string in this case. Maybe let's use banana, and again this needs to be list actually, so that we don't get an error. And let's pass in an apple, and let's pass in a pen, so that's no fruits, a pen. And from here if we run this, to randomly make a selection and give us something, and it selected the last one. If I run it again, it should give us something else and give us another thing. If I run it again, it should give us something else. And so it's randomly selecting from a list that will give to it. So that's how you do random. Of course, I've really introduced NumPy. NumPy is also another great package, and it has like, you could use it to do a lot of like linear algebra, doing trigonometric functions, has arrays and vectorized operations. So one example would be, let's create an array in this case, and in this array let's convert this list. I'll create a list and I'll convert this particular list to an array, and I need to have 2, 3, 2, whatever I want to pass in there. Now I have an array. If I check this type, it's an array actually. Sorry, I wanted to do a type of the array, and then it should tell us that it's a NumPy array, which is great. Now we could find the sign of this using NumPy. For example, this is trigonometry. You could do sign of the array, and this will give us the value. These are the values, these are the sign. So if you do a sign of 2, this is what you get, and so on and so forth. You could do the cos or tan or whatever you want to do, and it will give you the values. Okay. But you could also do like the determinants of a metric. For example, you want to do a determinant of a metric, then you just have to use the linear algebra. So that would be NumPy dot len algebra dot determinant, and in the determinant to pass in the metric. So the matrix in this case, we want it to be maybe 2, 1, and in the second one, or in the second row, we want it to be, maybe let's pass in a 3, 4. So this is a 2 by 2 matrix, and this will compute the determinant, and that's the determinant of that particular matrix. And so you could do things like that through in Python. The video is getting a bit long. Let me end it by doing something about symbolic computation with the SymPy. It's another great package for like solving equations, calculus, do derivatives and integrals with a particular one. And here's an example. So let's just import from SymPy, import. Let's import a few stuff that we need. Let's import symbols. Let's import symbols. Let's import the solve. Import solve. Let's import diff. Let's import integrate. Okay, and if you run that, those should all import. Now, if you have an x, b, if you have x to be equal to, say, let's just give it a symbols, and that should be x. What is x? Could someone guess? It's the symbol x. So you could use it to like type symbol x. So it's no longer the number x, but it has that symbol x now. And you could even do things like maybe the exponential of that particular x. And so we just have to do a square. Remember, that's raised to the power of 2, so that's the square of 2. And we could do a -4. So this is a form of like equation of a cycle. If you want to think of it that way, where y is t2 here, then you have that, and you could even check this particular value. And so we could do something like print, and let's solve this particular equation. So have the x, comma the x, exponential, comma exponential, and if you do that, then it solves it and gives us the two values of x. So if this is like a quadratic equation, it has two solutions, and the solutions are a -2 or a 2, and we'll have that. You could also do things like diff. So for example, if you say print diff, and we could pass in like x raised to the power of 3, and let's pass in the x. If we run that, then that should give us like a derivative of like x to the 3. Oh, where did I get something wrong? The diff of that reciprocal of 3x. Okay, yeah, that looks right. And then you could also do things like integrate, and you could print, for example, and say integrate, and in the integral raised to the power of 2, and you could pass in our x, and that will give us that. That's the integral. And so let me just end the video here, but there are a bunch of stuff, and this is just a little of things like gradient, div, squares, square roots, whatever you think of doing in math, you could do it in Python. So it's a great computation tool. See you in my next video, where I will be talking about loops. Until then, bye. Have a good day. And also subscribe.